So in this video we will demonstrate how you can assign unique specific codes, ordinal numbers, to your enumerated constants. So the syntax is constructor-like syntax. For instance, we want to make it 10, and then we want to make it 20, and then 30, something like this. So just unique numbers, but we'd like to customize them. So this is how we would like them to be assigned. So the next step is to actually store an integer, and we'll call it value. And so you begin to realize that you can actually add custom data attributes to the body of the enumeration class, and then we will add a private constructor such as employee type. So this is a constructor syntax which will take int value, and this constructor will be used by the compiler at the time when these ordinal numbers are assigned. This is why we keep it private. So this cannot be used outside of this enumeration. So they're just being used by the compiler once. And here we just simply say this value equals value. So we store the value, and that would redefine the actual values. So the values are hard-coded. They will be used by the compiler when it will decide to initialize these constants with ordinal numbers, and we tell the compiler what should be happening and where to store the value. So this obviously also will be private value right there. Okay, so let's run this sample with this change in place. So just run it. You see that our conversion to string continues to be the same, but if we'd like to revert back to the ordinal number like this, so if we want to display the ordinal numbers for our constants, let's see what this is going to display. And you can see, although we made those changes, expecting that perhaps these will be the values used by Java enumeration, but in reality you cannot assign the true ordinal numbers to change them. They're inherent, and they will be stored in the enumeration, regardless to those tricks. So basically what we need to do is also provide a custom method that will extract a custom ordinal number. So for this, of course, what we can do is just extract this value. So I'll try pressing Alt-Enter on top of this. And well, it doesn't really give me my option. So what I really want is to insert code, and it will be a getter for the value like this, and I'll say generate. So get value will give me the custom value for each of these ordinal numbers. So if we replace the ordinal with get value, this will be our best approach, the closest way of getting some custom values with our enumerated constants. So we run this version. So here finally we get 10, 20, and 30. So you can see that it's sort of a trick that is basically workaround the fact that you cannot change the true ordinal assignments, which is 0, 1, and 2, even though we tried to add a constructor syntax and try to assign something unique. However, we can have a specific method the getter to extract this unique value. So that's just as far as I would like normally to go with enumerations in Java. But for the most applications, it would be enough to rely on default assignment of ordinal values like 0, 1, 2, 3, 4, 5, and so forth, regardless how many constants you would like to include in your enumerations. So I would encourage you to consider using enumerated data types every time you have the need for a constant set of these unique constants that identify certain things like employee type and other unique assignments that you can have in your applications. So, for instance, another example would be like colors. So we can have red, green, and blue, and use them as enumerated type in your 3D graphics. So those are possible situations where enumeration would be a nice choice. So that all works, and compiler is very friendly in terms of handling the ordinal, the enumerated types. So we have some examples in our handout. And finally, if you'd like to import static fields from the statically defined data in one of your classes. So again, I am resurrecting these three integer constants, and if I'd like to use these constants elsewhere, I can actually import them like this, so that I don't have to use fully qualified class name together with them. I can use a static import. So here I can say import static, which means everything that's static is going to be imported in this file, and this is going to be week3 main app, and we'll just use an asterisk, which will import all static members, all fields like we have there. And so let's make some changes here. We'll just make this 100, this will be 200, and this will be 300. Right, and since I made my static import, now I can use these constants in this file without specifying that they're actually coming from the main app class. So here's just a little demo for the static import. So you can see that this may also be used, and this import static sort of behaves similar to enumeration, but of course it's much less restricted, because still there is no unique enumerated type. It's just an integer that uses specific unique values in this demo. So anyways, so we still have our get value. So if we rerun this example, right, so now I was able to import statically defined fields which happen to be also constant in my main app, and then I use them inside my enumeration, and of course those unique values I decided to use to initialize my custom value inside my enumerated type. So this is as best as I can try in this sample to demonstrate the possible use of the static import.